Okay, so today we're going to go over systems of equations with three variables. Now, system of equations with three variables, I have an example here, are basically when three 3D planes meet up on a single point in a line. So, while normally on a 2D coordinate plane, you'd have your simple x, y coordinates. On a 3D, you'd have your x, y, z coordinates. Now, this system of equations is basically creating three of these 3D planes, and they will all intersect at one point, creating our triple coordinate point. Now, a good real world example when it comes to these is if you're buying something at a supermarket. For example, Hunter goes out and buys 3 apples, 2 bananas, and 4 oranges, and totals out to $16, while Brianna goes out and buys 2 apples, 3 bananas, and 2 oranges, coming out to also $16, while Addie goes out and buys 5 apples, 2 bananas, 4 oranges, coming out to $24. Now, the key to solving this word problem will be to find the individual cost of each of the apples, bananas, and oranges. And you do that by isolating the variables. Now, let's learn how to do that. So the best way to isolate the variables is to cancel out the leading coefficients on the system of equations. So if we come over here real quick, we can take these two top systems of equations and write them out. A mistake there. Now, what we're going to do with this is we're going to make these two leading coefficients the opposite of each other. One will be a positive and one will be a negative. So what we're going to do is we're going to multiply the top one by -2. No, we're not. Give me a second. We're going to multiply the top one by +2 and multiply the bottom one by -3, which comes out to 6x, I apologize, 6x minus 4x plus 8y equals 32 over -6x minus 9x minus 6z equals -48. Now, we can cancel these two out since they are the negative of each other, which leaves us with -13y plus 2z equals -16. And now that we've isolated the y, we're going to create another small system down here. We're going to leave the top equation the same. However, we're going to put in our new equation down here real quick. And now we're going to do the exact same thing with the top and the bottom equation. So we're going to take 3x minus 2y plus 4z equals 16 over 5x plus 2y plus 4z equals 24. Now, we're going to do the exact same thing here. We're going to multiply the top by 5 and the bottom by -3. And that's going to come out to 15x minus 10y plus, I apologize, 20z equals 80. It equals 80 over negative 15x minus 6y minus 12z equals negative 72. So, same as before, these two coefficients first cancel out, leaving us with negative 16y plus 8z equals 8. And we're going to substitute that for the bottom over here on our next equation. Equals 8. Now that we have that all sorted out, we are ready to find our very last equation. Now, our last equation, most of the time, apart from a few very special cases, is going to be ARZ. In a couple notable cases, the last equation could be something like a number equals a number instead of z equaling a number. If it is the same number like this, that means that the coordinates are the same. The lines are all on top of each other, thus making it all real solutions. While if we have a number equals a number, but it is not true, that means the lines do not intersect at all. They're completely parallel and there is no solution. So, what we're going to do is we are going to take these two equations and set them equal to each other, similar to how we have been doing with these equations. And we are going to find our z variable. So, for some simplicity's sake, we're going to multiply this equation by negative 16 and this equation by, or negative 16y. Sorry, no, we're not by y. Negative 16 and this equation by 13, which leads us out to 208y minus 32z is equal to 256 over negative 208y plus 104z equals 104. Now, these two cancel out, and we are left with positive 72, my marker's dying, 72z is equal to 360. And we could put that, well, not quite yet. So now we are going to divide by 72 on both sides, creating z equals 5. Now we've completed our three systems of equations. And we have found our first point in our coordinates. So we have our x point, we have our y point, and we now know that z equals 5. So what we are going to do is we are going to plug z back into our equations, to find the other two variables. So if we take negative 13y plus 2 times 5 equals negative 16, we come up with negative 13y plus 10 equals negative 16. Subtract 10 from both sides. We have negative 13y equals negative 26. Divide by negative 13 on both sides. We come up with y is equal to 2, bringing us our y coordinate. And finally, we're going to take these two new variables we have found and plug it in to our initial equation here. It's going to look a little something like that. So 3x minus 4 plus 20 equals 16. Now we are going to combine like terms as per normal. So that's 3x plus 16 equals 16. Then you subtract 16 from both sides and get 3x equals 0. Divide by 3 and x equals 0. Thus making our solution to our system of equations the point 0 to 5 on a 3D coordinate plane. And that's how you solve a system of equations. Okay, moving on from our systems of equations with 3 variables, we're going to move on to our systems of inequalities. Our system of inequalities sits on a 2D plane instead of a 3D like our systems of equations. So let me draw a quick little graph here for reference. What we're looking at with the system of inequalities is basically a larger area that is a solution set. So for example, if we take this line, now normally our solutions in a normal line would lay upon the line itself, but as you can see within an inequality, it has a greater than, less than, or equal to sign. So basically what our equality will look like is something like this. Now instead of our solutions just laying on the line, our solution set lays in within the area that is shaded for the inequality. Think of it as more of a border for a larger plane. Now, a good real-world application to this problem set, I'll just erase that all and redraw it, is simply, if we have some students that are setting up a school dance, you see that? Yeah, you can see that just fine. We have some students that are setting up a school dance. They want to make around, let's say, $500. They want to make a certain amount of money, and they expect a certain number of students, let's say 300 students, to show up through that door. Now, obviously, they can only sell as many tickets as there are students. So, and they're selling 2 different kinds of tickets. They're selling advanced tickets, which are $3, and tickets you buy as you walk in through the door, which are $4. So, now this isn't going to be exactly the same as the numbers, but let's say that this line kind of approximates that around 30 students purchase tickets. And then we can shade above, because this is the potential, this is the solution area for how many students can buy tickets as they walk into the door. And we expect so many students to show up, and assuming that this line is the number of students not accounting for 30, they can buy however many tickets there are. Now, since we have 30 students already having bought tickets, that leaves this solution area that shows like how many tickets they have to sell through the door in order to make their $500 goal. Now, you can also use some different geometric shapes instead of lines. For example, in this problem we're going to do, we are using a parabola. And so we're going to start out with our line here. 2x minus y is greater than or equal to 1. Now we want to put this into y equals mx plus b. So we're going to do some reshuffling of the numbers. We're going to subtract 2x from both sides. It leaves us with negative y is greater than negative 2x plus 1. And then we divide out the negative 1, which leaves us with y is less than or equal to negative 1. Sorry, that's not, I forgot the 2x, 2x minus 1. Now, we have our y-intercept form. We are going to go ahead and graph it. Now, I'm not the best artist, so this graph is not 100% accurate, but it is pretty accurate. So, if we mark down our x-intercept as negative 1, go up 1, 2, 1, 1, 2, 1. That gives us our line. Now, in order to figure out which side of the line we need to shade, which one is our solution set, we're going to take a point on the graph and plug it back into our line. So the point we're going to take is the easiest point to do in these kind of problems is 0, 0. So we're going to do 0 is less than or equal to 2 times 0 minus 1. It's terribly written, I apologize. So then 2 times 0 is 0. So we come out with 0 is less than or equal to negative 1. Now, this is not true. So which means that 0, 0 is not in our solution set. So we're going to go ahead and shade in this side of the line. If it were true, we would shade in the part that 0, 0 is on, this side of the line. That is if it's true, that is if it's part of the solution set. Now, let's scooch over to the other side here. Now, we are going to solve our parabola. This is the hard part. We're going to take down the vertex form in order to find the vertex of our parabola. So, we have negative b over 2a, which is our parabola, or parabola form, vertex form. So, negative b will be negative 2, make sure we're putting in parentheses, over 2 times 1, which would come out to, give me a second, I apologize for the delay, it would come out to 1, since 2 over 2 equals 1. Now, we're going to take that and plug it into our equation here. Which comes out to 1 minus 2 plus 2 is that equation is going to come out to this negative 2 and plus positive 2 cancel out, so it's just y is less than or equal to 1, giving us our vertex of 1, 1, which we can come over here and graph, which is right here. Now, we're going to try and locate some other points here for accuracy. So let's come over to the side here, make ourselves an XY chart. And for the sake of time, I won't be doing every problem by hand. So we have 1, 1 is our vertex, 0 comes out to 2 on the XY chart, and 2 comes out to 2 on the XY chart. So we're going to come over here again and graph our points. So 0, 1, 2 is right here. Then we come over to 2, 1, 2 is right here. So we can graph our parabola, and we are going to put in our 0, 0 right here. So 0 is less than or equal to 0 squared minus 2 times 0 plus 2. So 0 times 2 is nothing, or 0. We don't need to put that on. 0 squared is nothing. So we have 0 is less than 2. Now, this is true. So 0 is going to be part of our solution set. So we see the solution set is outside of the parabola. So this entire area outside of the parabola is our solution set. Starting to look a little messy there. And now we want to know, what is our solution? Well, our solution area is the area where our two inequality, like shading, overlap. So we have our line here, our parabola here, so that would make this area, not including this little spot inside the parabola, our solution set for this system of inequalities. Now, that should be all. We have explained systems of equations and systems of inequalities, and I hope that covered about everything.